So now that we've gone through how to solve a quadratic equation or how to deal with these through factoring and then applying the zero product principle, now we're ready for the applications of them. Now that we're ready for the word problems. And as I go through these word problems, we're going to use the strategies that we developed in chapter 2, but apply them to these. And so each word problem is going to be worth 3 marks, one for the let statement, one for the equation, and then one for the answer. So again, we're developing the process and we're breaking these down to then build them up and give the final answer. So all of these, the equation that you're going to develop will have an x squared term in it, and you're going to rearrange it into standard form and use the zero product principle after you factor it. So let's try one of these, and maybe it's easier for me to show you what we're talking about. So this one says the product of two consecutive integers. And if you remember, consecutive integers were the x and the x plus 1. So let x be the first integer and x plus 1 be the next. And you know, they don't have to be even full sentences, but that idea that you've come up with what x is representing, it's a key bit because we're going to go back to that when we give our final answer. So this one is a little different than the last ones that we saw back in chapter 2, because now it says the product of two integers or two consecutive integers. It says that it is 132. So as soon as you see the is, that could be an equal to sign. And so really the key with this is that we're taking the first integer and we're multiplying it by the next. That's what product implies. And that should equal 132. So that is the equation that you're going to solve. And in order to solve this, we need to put it into standard quadratic form, then factor it and apply the zero product principle. This is not the 132 principle. We have to set it equal to 0 so we can apply the zero principle. So in putting it into standard form, we'd have x squared plus x equaling 132. And again, we need to set these equal to 0. And so you subtract 132 from both sides, and I get my equation that I can actually work on here of that, because it's set equal to 0. So now that I have it set equal to 0, I can go about factoring this. It's a trinomial without a greatest common factor, and the number at the top of my number puzzle is negative 132. 132 is a huge number. What I did, quite honestly, on my calculator is take the square root of it, because I know the factors are going to be different by 1. And so obviously 1 and 132 would be factors. And then I kind of skipped ahead and I tried 11 on my calculator. 11 and 12 are the numbers that would give you 132 as a product. Now, one's going to be positive, one's going to be negative. When the B term is positive, that means the larger is going to be positive and the smaller is going to be negative. If skipping, you know, some of the factors in your number puzzle isn't something you're comfortable with, then by all means take the time to list all of them. But in all honesty, 132 has a lot of factors, and I was kind of skipping to just get to the answer quicker. So on the topic of getting to the answer quicker, this one I can use my shortcut because it's a simple trinomial. So I'd have x minus 11 and x plus 12. Certainly, if you still want to factor through decomposition, you'll need to pause the video right now or use another piece of paper or what have you. You should end up to the same place as I am here with x minus 11 and x plus 12. So we've factored this. Now that we've factored it, the second step in solving these quadratic equations is the zero product principle. So either x minus 11 equals 0 or x plus 12 equals 0. So I have these two cases going on here. And so I have plus 11 on both sides, and I get x equaling 11, or minus 12 on both sides, x equals negative 12. So this is where things get tricky, and I put a little asterisk in the notes here. You have two options for your x value. And so we can take both of these and trace them back into our let statements. So option 1, if I were to take x and x plus 1, that would equal 12. So 11 and 12 are consecutive integers. If I took my other option and had negative 12 plus 1, so remember x plus 1 is an x, then I get negative 11. So your final answer here, you have 4 numbers, 2 different options. So the integers are this 11 and 12, right? Those are consecutive integers and they would multiply to give you 132. Or, check this out, negative 12 and negative 11. Because again, those two would multiply to give you a positive 132. And so we've answered our question here for the final mark in our word problem. Let's give another one a look here. So this one says the product of 2 consecutive even and positive integers. So when they're even integers, that's when we had the x and the x plus 2 as our integers. So if you just wanted to do your let statements like that, that would totally work. And again, this one says the product of 2 consecutive even integers is 120. So let's take a look at this. To build the equation, we would multiply these two expressions together because those would be representing the 2 integers. So that is the equation that you're going to need to solve. We need to put it into standard quadratic form, setting equal to 0, then factor and apply the 0 product principle. So I'm going to work on this one, kind of expanding it out. Subtract 120 from both sides because remember I want to set it equal to 0. And I'd get x squared plus 2x minus 120 equaling 0. I have this ready to factor now. It's a simple trinomial. Negative 120 would be at the top of my number puzzle. And you could factor 120 as many ways as you want. I'm going to skip to what I can see right off the top, that if we have a negative 10 and a positive 12, those would give me my B term. So I always do a bit of a number puzzle. If I don't do the complete list of factors, I at least show the ones that I'm thinking to double check and make sure that they actually satisfy, especially that second criteria of the number puzzle. So again, because this is a simple trinomial, I can use the shortcut. If you're not happy using the shortcut, then you could pause the video and take your time, or you can flag me down in the comments or make me stop the video in class. We should end up with x minus 10 and x plus 12 in our brackets. So now that we have it factored, remember that's the first step in solving these, now we apply the 0 product principle. So either x minus 10 equals 0 or x plus 12 equals 0. Those are the two conditions that would actually satisfy this equation that we have in factored form. So I'd keep going on these and I'd get that x equals 10 or x equals negative 12. And so like the last one, I have these two options, but you do need to make sure that you're reading the questions carefully because it does say up here positive. And so because I have positive in the question, that means I'm going to reject this option. We're going to reject it because it's not positive. And so now I could take the x plus 2 being 12 to get my final answer. So the integers are 10 and 12. And those are 2 consecutive even positive integers, and they would multiply to give me 120. Always double check that they do in fact make sense. A few more here. So this one is a geometry question. It's about a rectangle, and so I'm going to draw my rectangle. It says the area of a rectangle is 96 centimeters squared. So I know because the area of a rectangle, I have a framework equation. Area of a rectangle equals length times width. Again, in the geometry ones, I'm going to do these similar to the way I did them in chapter 2, where in the geometry I drew a picture, I labeled it, and I had this framework equation. It says here, if the length is 4 centimeters more than the width, find the dimensions of the rectangle. So when you're comparing something to something else, the thing you're comparing to gets to be x, and so my width would be x. And the length here, it says, I have to do some translating, is 4 centimeters more than the width. So x plus 4 would be the expression to represent the length. Now that I have my expression for the parts of my rectangle, I can put together the information from the question into the framework equation. So I could write that 96 equals my length and my width, and I'm going to write them in kind of reverse order because they look a little more sensible to me. Because now that I have my equation, I need to put it into standard form so that I can factor it and apply the zero product principle. So a lot of monkeying around with this one, trying to make it look a little bit more reasonable. I'm going to distribute that. I'm actually going to write it all on this side because that's the way I'm used to seeing it. And then I would subtract 96 from both sides. I just did this flippy flop thing here. Hopefully that doesn't mess anybody up. So regardless, you should end up with the same equation as I have here. So x squared plus 4x minus 96 equals 0. And again, we have to have it set equals 0 because now we can factor it. I have a trinomial once again, and so negative 96 would be at the top of my number puzzle. And this one might take some thinking. So 1 and 96, I know 2 would go, but that's not going to be 4 apart. 3, that's still going to be more than 4 apart. And I'd work my way up. I've done a little bit of thinking in advance. I've got 8 and 12. And again, I need a positive 4, so my larger factor is going to be positive. My smaller is negative. If the number puzzle bits are just going a bit too fast for you, it just takes time, and I didn't want to eat up a whole ton of time in the videos here. So you can kind of take it as a cheat almost that I've figured out the number puzzle for you. You know how to do it. Just take your time, list out all the factors. So now that I've got this, and again, it's a simple trinomial, I can use the shortcut. So I've got x minus 8 and x plus 12 equaling 0. Oftentimes in class, people make me do the long cut. So you're suffering through me teaching this without someone telling me to do the long cut. So here's the shortcut again. In this one, we've got now the zero product principle. So either x minus 8 equals 0 or x plus 12 equals 0. So this would give me x equaling 8, or this would give me x equaling negative 12. In carpentry, in geometry, we don't really have negative measurements. And so again, in this one, we're going to reject this negative because it doesn't make sense in terms of our context here. And so now that I have my x equaling 8, I could do the other part of it. We know that x plus 4 would be the length, and so that would be 8 plus 4 or 12. So that's what gives me my answer. The rectangle is 8 centimeters by 12 centimeters. And again, I rejected the negative because that's not how geometry works or how tape measures work. This next one is a bit of a bonus, and so I would encourage you just to kind of sit back and watch and enjoy for this one. Same with the next one. They're kind of weird ones, but I put them in here just kind of for fun, I guess. I don't know. This one's like a bonus type question. So it says in this one, the sides of a square are decreased by 2 centimeters, and then the area would be decreased by 36. So, we have the before and after, right? This is x and x of a square, right? And, x squared would equal the area. But it says that if I decrease the sides of the square, so x minus 2, the area is decreased by 36 centimeters squared. So this would equal an area decreased by 36 centimeters squared. And remember, the area was x squared. So this is why it's a bonus, coming up with the equation. I think it's really, really difficult. So area equals the sides squared, as we know. So in this one, stay with me, we'd have x minus 2 times x minus 2, right? Those are the sides squared. But we have our area, oops, sorry, I should do a couple things backwards here. So I'll just do this a little different. Sorry for the erasing. So area equals side squared. I did that backwards again. Side squared equals area. There we go. So this would be, really confusing everybody now, this would be x squared minus 36. So if you believe me or not, if you were given this equation, you have a lot to do in putting it into standard form. And so what we have going on here is x minus 2 times x minus 2 equaling x squared minus 36. And remember, this is a bonus. Don't freak out. And so I'd have x squared for first, outside, inside, and last. Man, it's huge. Still trying to put it into standard form, set it equal to 0. I'm going to gather up my like terms. I'm going to subtract x squared from both sides. And oh, look, it just goes away entirely. So now I have negative 4x plus 4 equaling negative 36. I'd have to add 36 to both sides because remember, I'm trying to set it equal to 0. And at the top of my page over here, I'd get negative 4x plus 40 equals 0. So in this one, I'm going to common factor. And remember, when I see the negative out the front, I'm going to take that as my lead. So I'm going to factor negative 4 out and be left with an x minus 10. And now that it's fully factored, I only have one thing to apply the zero product principle to. And so really what I'm saying here is x minus 10 equals 0. So I could add 10 to both sides, and I get that x equals 10. And that is the dimensions, those original dimensions of my square. So the square was 10 centimeters square, or 10 centimeters by 10 centimeters, if that's how you like to answer it. So again, with this one, the setup, what I put the wiggly brackets around, I think that just makes this a really beastie type question. I omitted any from the homework like that. There used to be one like that on the test, which is why I put it in the notes. But at this point, I can say that that's a bit of a bonus. It really does drag you through putting it in standard form and then apply the zero product principle. The next kind down here is another one that sometimes happens. So we've had our integer problems, we've had our geometry problems. Now we have one of these where you're given the equation. So it's kind of like what I was saying before. You don't have to come up with the equation sometimes, but you do need to use it. So this one is saying, suppose the cost in dollars, so that's what C of X is talking about. This is the cost of producing a certain number of stereo systems. So X is the number of stereo systems. And then this one, that tells us what X is representing. You don't have to give an X statement. So X is the number of stereo systems. And again, that one's given to us in the question. So this one specifically says, how many stereo systems could be produced for $7,500? So if this is your factory and this is how your factory operates and you have $7,500, we need to figure out how many stereos you could make. And so what we're going to do is put $7,500 in for the cost and then copy the rest of this. I'd want to put this into standard quadratic form so I can factor it and apply the zero product principle to solve for X, which is the number of stereo systems. So there's lots to do with this one. I would probably bring everything over, like all the whole numbers over to this side and set it equal to 0 on this side. I'm going to put it in descending order. So 3x squared, I'm going to subtract 7,500 from both sides. Sorry. You do this all in one step. And then I'd have negative 4,500 down here. So this is the equation that I can now monkey with to factor and apply the zero product principle. I did a couple things in one. Hopefully I didn't bungle you. So I've put in descending order and set equal to 0. Okay, so now that I have it set equal to 0, I mean, you could put the 0 out the other end if you wanted to. This one, you certainly want to greatest common factor first, because otherwise you'd have 3 times 4,500 at the top of your number puzzle. It would take you a day and a half to factor that one. So I'm going to pull a 3 out of all of this. So that would leave me with then a simple trinomial. And I'm still going to have negative 1,500 at the top of my number puzzle. So kind of like in a lot of these ones, I find that doing a complete factor chart is definitely a recipe for frustration. And I might start sort of just thinking about what two factors would be 20 apart. Well, what about 30 and 50? They would multiply to give me 1,500. Now, the whole thing with the signs, I'm going to need a positive 30 and a negative 50 because I want to get to a negative 20 as a sum. So those are the numbers. I could decompose my middle term, but this is one that's possible to use the shortcut. So I could write it in factored form as 3, don't forget about that one, x plus 30 and x minus 50. Now that I have it factored, I can apply the zero product principle. The 3 doesn't have an x part of it, so it needs to be in there to preserve the value, but it's not going to be part of my solving for x. So either x plus 30 equals 0 or x minus 50 equals 0. So subtract 30, we could get that x equals negative 30. So well, you could just go out and buy 30 stereos, which is what this is saying. We don't want a negative number here. So let's keep going on this one. Hopefully it comes out positive. X equals 50. So what this is saying is that you could make 50 stereos in your factory that operates on this model, mathematical model, for $7,500. So you could make 50 stereos. And that's your answer. That's it for the word problems. There's fewer kinds. On the back side of the page here, there's just a few more because I find that sometimes people get, just a little bit forgetful or can use a recap. So if you're feeling good, you can ignore these ones, but there was just a bit more space on this page. So just pulling this all together and leaving off our chapter 4 material, this one we're going to solve for x, and that's where we got to in this 4.6 section and the word problems. But remember, we had to set them equal to 0. So this one I can move the 5x and the 2 over to the other side. I could rewrite it as 3x squared minus 5x minus 2 equaling 0. And you could do that in a couple steps. I did it in one because I was feeling lazy. Okay, so now that we have a trinomial, I'm going to do my AC test. I'd have negative 6 at the top of my number puzzle. And this is one that I can't use the shortcut on because I have a coefficient out there. Another reason I put this example in because we've done so many with the shortcut. So factoring 6 in as many ways as possible, I see that I have a negative 6 at the top. The other reason I put this one in is that it's really easy to pick the wrong factors. The correct factors to pick would be positive 1 and negative 6. That would add together to give me a negative 5. So those are the values that are going to decompose my middle term, remembering because I've got a 3 out the front, no shortcut. So 3x gets copied, plus x, and negative 6x, decompose my negative 5x there, and then negative 2 and equal to 0. Factoring by grouping, pulling an x out of the first two terms, and then looking at the second two terms, I'd pull a -2 out and be left with a 3x and a +1. So now that I have it factored by grouping, I see that I've got a common binomial factor, so write that out the front and fill the brackets up with what's left over when I divide that out, so an x minus 2. Now that I have it fully factored, remember this is factoring, I can solve this with the zero product principle. And so that would have me say that 3x plus 1 equals 0 or x minus 2 equals 0. So solving this one, I'd get that 3x equals -1, divide by 3, and x equals -1/3, or with this one, x could equal 2. So those are your options here. You've got two options. So just one more word problem, and we're going to round this out. This one says, because we all love them, the square of a positive integer is 56 more than the integer. And this one, we only have one integer, so let x be the integer. Not a consecutive integer problem, just an integer. And this is all about translating. So the square of an integer, and it says say positive, so we're going to reject that negative, so that would be x squared, is 56 more than the integer. And so crafting your equation is all about the translating here. And I threw this one in because I know how much people don't really love translating sometimes. So putting this into standard form in one step, I'm going to factor this. It's a simple trinomial, so -56 at the top. And I want two factors that are different by 1. So how about 7 and 8? They would add to give me my -1. And because it's a simple trinomial, I can use the shortcut. I can now apply my zero product principle. So x plus 7 equals 0 or x minus 8. Solving these two little independent questions, I get that x equals -7 or x equals 8. Now again, this one says positive, so I'm going to reject this negative option, and that's my answer. The integer is 8. And you can always double check this to make sure, like put it back into the equation, assuming your equation is right, to double check. So that's chapter 4. A lot in the skills of factoring. The word problems are a lot lighter than the word problems in chapter 2, and we're building on all this stuff. So remember your process in the word problems, and break it down. So slow it down, do a let statement, an equation, and then make sure you're answering the question. And if there's anything that causes you to reject an answer, make sure that you're thinking that one through.